Okay, we are about ready to get started, and I want to welcome everyone to this morning's program. I'm John Ramico, I'm the Director of Distance Learning Services here at WVIZ. We are located on Playhouse Square in downtown Cleveland, Ohio. And this morning's program is actually an entry into October, which is being celebrated as Manufacturing Month. And with us today, we have a corporation involved in advanced manufacturing. We have two schools. We have Beaumont High School and also Cuyahoga Community College. Both of these organizations, both of these schools are actively involved in the STEM program, pre-engineering, and are going to be talking this morning about some of their exciting robotic projects. But before we get started, I just want to remind the schools that this is going to be an interactive session, and at the end of the session, we're going to ask if you have any questions. When it's time for questions, we'll call upon each individual site. We would like you to introduce yourself with your first name, and then ask your question, and then put yourself back on mute. That will keep your site on our monitor so that our guests can respond directly to you. And we would love you to please keep the microphone on mute throughout the program until it's time for questions. It just makes it a whole lot easier for us as we focus on the different schools that are participating in the program here. Again, welcome. Our program today is Connecting STEM, Robotics, and Advanced Manufacturing. And with us today, as I mentioned, we have three organizations. We have Nordson Corporation, Beaumont High School, and Cuyahoga Community College, Tri-C. Probably if I say Tri-C, it'd be a lot easier than spitting out Cuyahoga. I worked for 24 years at Cuyahoga Heights, and I'm still spitting that out also, all right? With us, though, let me introduce the schools, okay, that are at a distance. We have Max Hayes, we have iSTEM, Geauga County, Warrensville Heights High School, Newark High School, Youngstown Cheney, Dunbar, Dayton Dunbar Early College, Revere High School, and also Northeast Metro. Here in the studio, we have students from Polaris Career Center and Lorraine High School. So again, I want to welcome everyone to the program. Our focus today is to give you an opportunity to take a look at what's happening in the areas of advanced manufacturing. Years back, we had the old dirty foundry, and some of those foundries still exist today. But foundries have moved into the modern days of high-tech manufacturing, advanced manufacturing. And that's where we are today with the companies that have been a part of our magnet program for the last 4 or 5 years. And it's very important that we thank Magnet for sponsoring these programs and hosting these programs. They have worked diligently in using the different companies here in Northeast Ohio to bring programming again to you students across, not just Northeast Ohio, but Ohio, and actually we extend sometimes across the country. So again, a huge thank you to Magnet for their work behind the scenes. I'd like to get our program started right now, and we're going to first of all have Nordson speak to you, and then the ladies from Beaumont will talk to you, and then we'll have a real live demonstration from Tri-C with regards to their robotics area. So I'd like to introduce Monica Davis, who's going to move ahead with our Nordson program.
Thank you, John. Hello and welcome. Again, my name is Monica Davis, and I am manager of Nordson's Student Outreach Program. In that role, I have the responsibility of managing our college scholarship program called Nordson Builds. In addition, I get to travel across the country and speak with young people just like you about the opportunities in manufacturing as a career and how manufacturing is a part of our lives each and every day. So what does Nordson manufacture? How many of you woke up this morning to an alarm on your cell phone? Okay, quite a bit. Okay, so today you touched Nordson because inside the chips that are soldered or melted together in your cell phone are made using Nordson equipment. Okay, and hopefully many of you took a shower this morning. How many of you took showers this morning? Great. Okay, I'm sure you use shampoo or liquid body soap. Well, again, Nordson's equipment is used to do the plastic in this bottle. And so again, Nordson's equipment is touched by all of you each and every day. Okay, and let's see, for lunch, some of you may have a pop or a can of soup. Inside, there's a protective coating. It's Nordson equipment that is sprayed inside to keep the bacteria from coming into your food and to preserve it. Let's see. Cereal. Did anyone have cereal or orange juice for breakfast? Okay, great. Well, Nordson equipment is used to glue these products together. So in packaging, we use our adhesive dispensing systems to glue products together like these. Okay. And did anyone come here in a car or a school bus? Okay, many of you. So those automobiles were sprayed using spray guns manufactured by Nordson. Now we're going to show a little video to show you a little bit about Nordson as a company and its products.
Has partnered with the National Robotics League to create an event to engage high school students and spark interest in manufacturing, science, math, and engineering. 35 high school teams have partnered.
No,
The one from their, she said their second from Beaumont.
the one that you sent to us. Remember that you,
Oh, that, you didn't tell me that, John. Seemed like
Okay, we can chit chat while we're getting this one up. We'll get it up.
it's up here, I got it. You could.
Okay.
Okay, while they're getting the video together, just want to let you know that Nordson is part of your lives each and every day, and it's everywhere in every product almost that you touch and experience. And today you're going to be asking questions to our panelists, and I want to introduce them now, and then after the video we can ask them a few questions. First we have Seth Pisanelli. He's a machinist. In his job,
processing, testing and inspection.
okay, I think we have the video ready.
Surface
Great.
treatment, and fluid management. Our know-how is critical for products the world uses every day. Nordson, Precision Technology Solutions.
Gotta roll with the punches.
You can look almost anywhere in your daily life and say, okay, Nordson had some impact on that product. And the way we have an impact on the product is either making the product better through new features or making the cost better because we've been able to help our customers lower their cost of ownership. So we succeed, we win in the marketplace if we can enable our customers to win.
The company is headquartered in a state-of-the-art green facility located in Westlake, Ohio, and employs approximately 4,000 people in more than 30 countries around the world. With a leadership team committed to growth and continuous improvement, Nordson operates in 3 global segments, providing value to customers in a wide variety of consumer, non-durable, durable, and technology end markets.
So within each of the businesses, we have all the critical functions. Well, we have the technical sales force, we have the applications team, we have the product development group, we have the service organization, we've got a responsive supply chain. So at the end of the day, the customer experience is very good.
Nordson co-founder Eric Nord once said, "My hope for Nordson is that we continue to be a venturesome company, operating somewhere out on the leading edge. This can only happen if we continue to encourage innovators and entrepreneurs. This is Nordson. We deliver precision technology solutions to help customers succeed worldwide."
Okay, let's come back to our panel.
Okay, that video was made about 2 years ago, so today we have close to 6,000 employees. And today we have 3 of those employees that work in our industrial coating systems business in Amherst, Ohio. Amherst is where we were founded 60 plus years ago, and it's about 50, 60 miles west of Cleveland, Ohio. First, we have Seth Pisanelli. He's a machinist. In his job, he reads plans to assemble parts to precise specifications and uses instruments to ensure perfect measurements and top quality. Next, we have Elizabeth Irizarry. She's a product portfolio manager. She must have expert level knowledge of the products Nordson makes and find new ways to attract customers so we continue to make a profit. Last, we have Anthony Valletta. He's a production supervisor, and he's responsible for overseeing about 40 employees who work as assemblers and nozzle grinders. Welcome to our panelists.
Thank you.
Thank you. So first question, what do you like working for a company that manufactures industrial products?
I think it's really awesome to see the end product that we all have and thinking about the process that was made to put it all together. And it's really cool seeing the behind the scenes between all of those products.
I work in marketing, and what I really enjoy is the challenge of working with products that my customers aren't really looking for the gut emotional reaction to it. They're really looking for the function of the product. What are their features and benefits, and how is it cost effective to them? So it's a little more challenging to really get at the roots of the product, but it's a lot more fun, I think.
I'd have to say my favorite thing about dealing with a big company like this is that no matter what, you work with things that go into everybody's everyday life. I mean, like Monica said, everybody deals with pretty much something that Nordson had to take part in, so that's pretty cool.
Awesome. So how do each of you use science or math in your job?
Well, in marketing, you have to love data. Marketing is a very data-driven world these days. So looking at numbers, looking at how to analyze them, use any statistical analysis, and really interpret that data is important. You know, it kind of gives us our heading on which way we go in the marketplace and what we do with the next generation of products. So.
Me being from the machine shop, I deal with math all day, every day. Whether it be using your micrometers or calipers to check a part to make sure that it's within your tolerance zone of your measurements, or converting fractions to decimals, or putting offsets in the machine to tweak your part to make it to the print size. So math-based, very much so.
Okay.
I use math every day. Every day we're responsible to get out a certain amount of products that day in order to meet our customer deliveries. So it's similar to you guys is you have homework assignments after school and you have to get that done in order to go play outside or play video games. And so using the math to calculate how much time that's going to take in order to get those things done is what I do every day. And it's always a challenge and always fun.
Great. This next question is especially important for young people, but what kind of training did you need to prepare for your job?
Mainly, you got to have a good work ethic. I went through a program through the Lorain County JVS, a 2-year prep program in the machining field, where it kind of gives me the basic knowledge of what you need to know to get into the machining field and kind of give you a feel of what you're going to be dealing with. So.
And Seth, explain to us, what does a good work ethic look like?
A good work ethic is, definitely be willing to learn, go above and beyond, show up on time, don't make excuses for being late or not showing up, and just come up, do your job, and be willing to learn and go home.
Great.
Some training I had an internship at Nordson in the quality section of the business of making sure our products are up to date and fit our customer demand. But then I finished my college education and came back as a supervisor. And I was given on-job training and management training to deal with a lot of different people and personalities that we all have.
Well, definitely, college degree definitely helped. But any project that I had with an actual company or my internship I had, any time you face real world experiences, I think that's where you learn how to really grasp a challenge, understand the variety of challenges a company may face and how your skills can develop and improve and apply to that. Really kind of helped prepare, I think.
Okay, so it sounds like education beyond high school got you in the door, but what kept you there were the relationships that you made, your communication skills, your work ethic, and some of those soft skills that we still need to develop, and you have that opportunity to develop in the workplace. Okay, great. Okay, what other skills are important to succeed in your job?
In my job, I think it's management and leadership. It's being able to kind of take in all of the information around and make a decision and go with it. It's figuring out what's going on and make that decision and then provide support in order to get that done.
For me, communication is huge. So marketing works in between a lot of the different job functions. So we're always kind of like the centerpiece of taking information from sales, interpreting it to a product that we need from engineering, making sure orders are going through the door, and talking to production to make sure that we're, getting orders going. So communication is huge to make sure all the moving pieces are going. Alongside of that, problem solving, figuring out what consumers are wanting these days, what our customers' challenges are, and how can we fix them, and how do we apply them to our products. So you have to constantly get to the roots of something and trying to understand and always ask why. So
I'd kind of have to agree with communication and problem solving within the machine shop, because there's never going to be one problem that you have every day, and it's always going to be a different problem, and you got to solve it. And you have to solve it whether you figure it out yourself or you go to one of your fellow employees and they can come over and help you figure it out. But you got to be able to work alongside with other people, no matter what. Makes the day go by a lot better.
Right. Okay, Anthony, you manage the people that make Nordson's products. What skills do you see in manufacturing employees who are successful in their careers?
Well, I think the common factor, there's three kind of common factors. There's drive, there's passion, and attendance. There's the drive in order to want to learn and continue going. There's the passion in order to be excited about whatever you're doing, whether it's grinding a nozzle, whether it's assembling a product. And then there's attendance. Half of life is showing up. And if you show up on time, you're late. So show up 15 minutes early. But really, I think if you are there and you have the passion in order to do things and you have the drive in order to continue to learn and get through the tough times, I think those are the common factors that I see in successful people.
Great. And what skills do middle and high school students need to sharpen now while they are still exploring their careers?
Well, definitely communication, learn how to work in a team, work on projects. There doesn't always have to be one leader. You guys can always take a stand yourself and try and, help guide the group. So, definitely work on that. And problem solving, always ask why, always trying to understand. Don't try and just execute, but really trying to understand how you're doing it and why you're doing it. I think could be really helpful.
Anything else?
I kind of touched a little bit earlier on work ethic. In order to have a good job in life, you got to have a good work ethic. If you don't have a good work ethic, you're not going to go very far, plain and simple. The reason that I got so lucky as to get hired into a place at Nordson was because I'd show up to school on time, do my job, and keep my attendance up. All the good traits that you gotta have kind of play into getting a job, just like how your teachers look at you. So show up on time, do your job, be willing to learn, go above and beyond, and you'll do fine.
Anthony?
I think part of it is continue those math skills. As you heard, we all work with math each and every day. But also a little bit of the technical piece. I know you may love to play video games or play the games on your phone, but actually learn how that happens. How do you do that? Because with the way the world is going, technology is continuing increasing in our lives, and we need to learn and continue to learn how that is affecting and how we can take advantage of that going forward.
Great. Thank you so much to all of you.
Okay. We want to thank Nordson, and we'll come back with questions after or towards the end of the program. So Nordson's going to leave the stage right now, and Beaumont's going to come up. So Nordson, if you would move right, please, and we'll get one more chair up here for our Beaumont group. Going to turn the program over to Yvonne Schiffer. Yvonne?
Beaumont would like to begin our presentation with a short video from the Alliance for Working Together's Robobots competition, or the AWT BattleBots.
Design and build a robobot. Today, these teams set their creation against each other in battle. Safety is our primary concern. Teams attend safety meetings and are mentored by representatives of the partner company. Each robobot must have visible safety locks on its weapons. Before each match, the robobot must safely pass a safety and control test and may not weigh more than 15 pounds. Each team is allowed one opportunity during the match to have their robobot turned over by the referee. Teams may also withdraw from a match to refrain from taking more damage. Matches can be won outright if your robobot can cause enough damage to disable the opposing robobot. If after a 3-minute match, no winner has arisen, the match will be decided by a panel of judges. The robobots are judged in 3 areas: exhibited control of the robobot, aggression demonstrated during the match, and damage caused to the opponent robobot. This competition is a double elimination tournament. If a robobot is defeated in battle, it moves to the consolation bracket and continues in the competition. Each team is guaranteed a 20-minute period between battles to make repairs to their robot. Welcome to the AWT Northeast Ohio Regional Robobots Competition at Lakeland Community College.
Thank you. My name is Yvonne Schiffer. I am a retired product development engineer, currently teaching pre-engineering at Beaumont High School. This will be my 3rd year working with the robotics team, competing in the Alliance AWT's Robobot competition. Beaumont has participated for the last 4 years with all-female teams and had great success both locally and at the national level. AWT manufacturing partners have worked tirelessly with many local schools to expose students to engineering and manufacturing. This activity is open to all students with a wide range of skills and abilities. They learn both manufacturing skills and employability skills while they design and document the process of building a 15-pound combat machine. At Beaumont, there are very many young ladies who have changed their viewpoint about manufacturing and engineering from their exposure to this activity. AWT works with each team to provide an industry mentor with support and capacity to build the robot. I've had students who've used this opportunity to get summer employment, senior projects, on their way to college, on their way to employment. They have hosted us for guest speakers, field trips, shadow days, senior projects, and summer jobs. The goals of the competition are to develop technical skills in design and manufacturing, teach everyone to manage their time and the goals, both work independently and as part of a successful team, be accountable and productive, demonstrate integrity and ethical behavior. Participating in the AWT has been a rewarding experience for me, my students, and all involved. It has opened many doors for us. I'd like to introduce Gretchen Santo, Beaumont's robotics mentor and coach.
Thank you. I hope you found the little video segment as exciting as we do. Today we have brought with us 2 of the 6 robots that Beaumont has created over the last few years. These 2 were both featured in the segment that you got to see. This is the 5th year that I have coached a robot team. Beaumont is an all-girls school, and it is the only all-girls school participating in the AWT Robobot competition. We started with 1 team 4 years ago. We then found that there were enough students interested in robotics that we could make a 2nd team. The original team that I coached for 4 years graduated in June, and they have all gone on to universities where they are studying STEM-related fields. They had the privilege of being mentored by terrific professionals at a fantastic company called Christopher Tool and Manufacturing Company in Solon. The mentors there guided and encouraged the students in all aspects of building a combat robot. Both of the Beaumont teams have won many awards at local and national levels. Examples of this are Best Documentation, Best Presentation, best engineered, and first, second, and third places in combat competitions. One award of which we are very proud is the Best Engineered Robot at the NRL National Competition last year. The judging for this award included documentation, presentation, and combat performance. Our competitors came from high schools, technical schools, and colleges nationwide. Our girls have been featured on CNN, Amy Poehler's Smart Girls site, and even Chelsea Clinton on her Twitter account tweeted about the Beaumont team. The team members who will share their story with you today are beginning their third year of building combat robots. Margaret Schiffer will begin by telling you about her favorite parts of the design process.
Thank you, Mrs. Santo. I think one of my favorite parts of the entire experience was the first meeting when we met at the sponsor and we sat around a big business table to set the grounds for what our robot would be. We went around the table, no criticism whatsoever, voicing what we thought should make the perfect combat robot. I learned a lot about my teammates at this meeting. It was a very interesting process. We took all of our ideas and built a prototype using the best parts of the designs out of cardboard while referring back to the rulebook to ensure we were following the competition rules. We did a lot of research too, both before our brainstorming and during the process. We looked at different bots from past competitions. We discussed what we wanted in the design and safety, the different defensive mechanisms of the bot, and the offensive or weapon of choice for the bot we plan to build. I think that over the years I've participated, I've really gained a sense of the importance of communication. Without communication and documentation, nothing can get done. People are unaware and uninformed. That's why it's extremely important to communicate with everyone involved in the process. Now that I have learned the importance of the skill of communication, I can adapt it to whatever lies in my future. Now Holly Sirk would like to discuss the manufacturing process and competition involved in the Robotics League.
Thanks, Margaret. During the manufacturing process, most teams have a corporate sponsor who helps support the team financially and provide professional insight for the creation of the robot. During our first year, we had a corporate sponsor, but last year we weren't fortunate enough to have one. We were provided with a $1,000 grant from Cleveland State's Fenn Academy and the equivalent of $1,000 worth of parts from the previous robot that we built. We had to purchase everything and keep a record of our budget. Additionally, we relied on knowledge from our school and extracurricular activities to gain success. For example, I used knowledge from my pre-engineering class to create CAD drawings of the robot. Manufacturing requires problem-solving skills to create the puzzle that is the creation of the best robot. The competition is the climax of the season. Each battle is a maximum of 3 minutes, but will end if a battery becomes exposed, one robot stops moving for 10 seconds, or a team decides to tap out. Some competitions allow for a flip if the robot is stuck. If a competition comes to a full 3-minute end, judges decide the winner of the battle based on aggressiveness, damage to the other bot, and control. Competitions provide huge time crunches because you are only guaranteed 20 minutes for robot repairs, although most teams have more than 20 minutes to complete their repairs. Last year, during our competition, we had to replace both top and bottom plates of our robot within 30 minutes. Problem solving is a skill that will last me throughout the rest of my life, and I learned it from robotics. Now, Allie Noy will tell you about documentation and presentation.
Thanks, Holly. Documentation is also an essential component of the robot building process. Over the past 2 years, our team has adopted a common engineering principle, which states, if you didn't document it, it didn't happen. Every step of the process is documented, from brainstorming to manufacturing to CAD design. This documentation allows the process of building our robot to be completed by anyone who would like to repeat it. We create a documentation binder that aligns with the technical steps of the design process. It is 200 plus pages by the time we are finished building the robot, and it contains documents that are written by all team members. We create an action plan that contains tasks that are completed and need to be completed, take detailed meeting minutes at each meeting, and create a budget of all our expenditures. At the local AWT and national NRL Robobots competitions, we also present about the process in front of a panel of professionals in the engineering field. In the future, I would like to pursue a career in medicine. Although it is not in engineering, I still have learned many lessons, including the importance of hard work and teamwork that I can use in my future career.
Show the last clip.
Yes.
So the video you're about to see is shot from an onboard camera on our robot. And we decided to attach one of these so that you could actually see.
That's the board meeting. You have to take it back.
It is all the way back. This is the
It says Beaumont Tempest.
It was the second one that was in the email.
Right,
Yeah.
second one, right.
Well, while they're bringing it up, the video you're going to see is an onboard camera from our robot, so you'll actually be able to see what it's like in the competition. So the robots actually are in a bulletproof cage, and there's, like I said, there were 3-minute battles. So you'll be able to see how it actually looks when you're watching a competition. Keep bringing it up.
In this battle, our two Beaumont teams are actually opposing each other, so you'll be able to see our robot from last year, the Tempest, fighting Joan of Arc, and you can see Joan of Arc destroys us. We get
Yeah.
flipped a few times,
Yeah.
but it's very entertaining to watch, and you'll be able to see what a
So
point
the
of view.
onboard camera is docked on this robot so that you can see this one. There it is.
There it is.
All right. So this is just a little view, and what you see on the sides, those are safety measures. So as part of the robotics competition, we all have weapons attached to our robot, and this is us entering the cage. So we have to protect our weapons so that we don't injure anybody outside of the cage, and you can only remove them in the cage in a enclosed setting. So you'll see this robot. They're removing the safety the safety precautions on the weapon. So there isn't any sound on this video because the camera that we docked doesn't have any sound, but it's usually a lot louder at the competition because it is in like a gym. So there it goes. There's the weapon starting up. And there's the team on the other side. There's the other Beaumont team that graduated last year. So you can see they're controlling it from the outside of the cage.
The camera's on your...
Yes, the camera's on our
It was on
robot.
this robot.
On this one, yeah.
And you can see what the actual robot's being seen as it gets flipped by the other team. So we get flipped a couple times, and it's really cool to watch how the robot actually like takes the damage and keeps driving, even though it basically is getting beat up and destroyed. And if you look at our robot here in the studio, it has a lot of nicks, and there's a lot of things wrong with it right now. We had to hammer out the top and bottom plates and replace them. So there was just a lot of damage done to the robot. So we eventually ended up tapping out because there was so much damage to our bot, and we didn't want to go through a full 3-minute battle. So that was just a little preview of how the robotics competitions go.
Okay.
Okay, we're back. Well, thank you so much, Beaumont. We're now going to move over to our other area here in the studio. So audience, if you would like to move over and again, stay behind the cameras and also behind the table. Mr. George Belankowski from Cuyahoga Community College and his team is going to now show you some demonstration. And I need to move the camera here.
Back there, you're gonna balls all over the place. That's what you do over here. Just roll the balls back on.
Nora.
There, squeeze over there.
Come stand with us.
Just roll the balls back onto the field.
Some of you guys going over against the curb. They walk across the.
Yeah, go ahead. You can walk across the field.
Go ahead and walk across and get over there.
You're actually our board.
Okay, we're good, Bill? Or
Good to
George?
go. Hello, everyone. My name is George Belakonski. I'm the Executive Director of the Technology Academies at Cuyahoga Community College. And I'm here to talk about some of these toys that you see in front of you. And I think while I'm talking, we're going to have some of the students that are part of the VEX Robotics competition drive their robots around and shoot. So go ahead and start that up while I'm talking about this. You're going to see some outstanding robots here in a few minutes, but in order to get to the point where you're able to build the competition robots, you have to start by taking our entry-level robotics class, and that's the EET 1100 class. And this is the robot you start with. And once you figure out how to build this, then you can go on to the competition robots, and you'll see those in a minute. Here you go. The robot you're looking at right now actually scored the highest number of points in the state of Ohio and tied at 159 points with the entire country 2 weeks ago. We're not sure what the highest score is right now, but 2 weeks ago, that was the highest scoring robot. So if you could just pause for a minute right now, okay? Just stop for a minute, let me finish this, and then you start driving around. I wanted you guys to see that because it all starts here. This is your basic robot. This robot has a touch sensor, has optical encoders, has a line following device on the bottom, has a sonar sensor, it has a potentiometer on the side. And these are all sensors that you need to learn how to control, and you program them using the C programming language. And once you figure out how to do all that and come up with an idea for the competition, then you can build the bigger robots. You can't just walk in there and start building those. There's a lot that goes into it. Another platform that we use, which is really popular, is the Arduino robot. This is a little computer, and it costs about $5, and it powers this robot, and it does the same thing that the bigger robot over here does. It has a potentiometer, has sonar sensors, has line followers, has a touch sensor that controls different aspects of the robot. And again, you have to program it in the C programming language. This Arduino processor is used for a lot of things, and it's really popular right now. And it's also part of our EET 1100 class that students take. Another class that the students take deals with this computer. It's called the Raspberry Pi. It's a Linux computer. It's a full-blown computer, even though it's this small. And what we do in our class is we show the students how they can add a touch pad or a touch monitor. And it also has a little pen that you can use to write on the screen. It has HDMI output, so you can hook this up to your TV if you wanted to. You can play movies. You can download movies. It's a full functioning computer. Comes with a keyboard. This is your keyboard, and this is your mouse. And this is part of our program that we offer at Cuyahoga Community College. And by the way, all these classes that I'm talking about allow the students in high school to get college credit while they're still in high school. And they also get credit during their high school class, whether it's in math or science or if they have an engineering program. So this is all done either during the school day or after school. Now, this is pretty cool. Okay, this is like state of the art. This is a racing quadcopter that our students build. And again, this is another class that we offer. But before they build this, they have to take a CAD class to learn how to reverse engineer all the pieces and parts so they can take this over to a machine, cut out the pieces and parts and assemble it, and actually build a quadcopter. This is a racing version that we teach how to program. And again, it's using the same programming language that we used in these two robots. It's the C programming language. This has all sorts of sensors that go along with it. You have a GPS control, which allows you to identify where it is in the world, so you can actually pinpoint certain parts to fly to, or locate your quadcopter and bring it back. You can attach a camera to it. There's a lot of things you can do with it. This is a bigger version of the same thing. This thing costs quite a bit. This will stay up in the air for about 30 minutes. It'll take a full camera, a 35 millimeter camera. Here we have a smaller digital camera mounted on here. But this again will fly up in the air for 30 minutes, and you can film a football game, you can film your house. There's a lot of applications for it, and you know, from what I understand and from what you read in the news and what's going on in the world right now, these are eventually going to be used to deliver packages to your home. Amazon is looking at it. Domino's Pizza is looking at delivering pizzas with drones. How cool is that? You're standing somewhere with your cell phone, you say, I want a pizza, and this quadcopter delivers a pizza to you. That's pretty awesome. And I'm sure there's a whole lot of other applications I haven't even thought about yet. And it's really up to the next generation of innovators to come up with those applications. Here's one I think is really cool. This is a pocket drone, okay? It unfolds, all it needs is a couple of motors, and you can fly this. And this was all done on a 3D printer. And again, this is the technology that's out there. These are the classes that we offer at Cuyahoga Community College. You can get college credit while you're taking these classes, and you also get high school credit while you're taking these classes. And I guess what I want to do now is actually show you what the kids have actually come up with. And I'm going to ask Rico to come over here to talk about this competition. Where's Rico? He's one of our students. Why don't you explain this competition and what they're going to do and let them drive the robots around?
So Vex is a company that manufactures robot parts, and we buy the parts and use them to build robots for the competition they release every year. So this year's game, Nothing But Net, is played on a 12 by 12 foot field, and alliances made up of 2 robots each. So on your alliance, it starts off with a 15-second autonomous period written with pre-programmed C coding to have your robot perform tasks to score more points. The winner of the autonomous program gets a 10-point bonus. Then you're followed by a 1 minute and 45-second driver control period where you drive your robot and score into the nets. Each green ball in the net is worth 5 points. Every orange ball in the net is worth 10 points. And the last 30 seconds of the game, you can climb on top of your alliance member to gain 25 or 50 points. 25 if you're 4 inches off the ground, 12 if you're 12 inches off the ground gets you 50 points.
So why don't we go ahead and start the robots up and drive around and show everybody what they can do. I'm going to ask the other students to help out as the balls go off the field. Go ahead and put them back in. We've been very fortunate with our robotics program to have sponsors that help us get the competitions and actually pay for the pieces and parts. And the major sponsors for this competition, those that help us are NASA Glenn Research Center. We also have the Lennon Foundation. Nordson has helped us in the past. Rockwell International. These are all major sponsors. And the reason why they want to help us and they sponsor these programs is because they realize that they need technicians in the future. They need people, students that understand the technologies that are out there, that can manufacture the pieces and parts that are required to get into industry. And without their support, we wouldn't be training these students. Now, unlike BattleBots, they're not supposed to hit each other and destroy each other. But that does happen. When you put a joystick in a robot in the kid's hands, you know, stuff happens. Now remember, I showed you the robot at the beginning of the presentation. It's a very small robot. If you can imagine, if you're a student and you're trying to figure out what sort of robot you would make for this competition, just think about it for a minute. Would it be this kind of robot, or do you have a better design? If you look at these robots, they're actually quite complex. There's 3 different stages. They're picking up the ball, they're holding the ball, and then they're shooting it. Those are 3 different components to the design of this robot. And it took some time for the students to figure it out. Some of the other classes that we offer at Cuyahoga Community College, the high school students are also involved in industrial maintenance as well as mechanical engineering. And I already mentioned electrical engineering. These are all classes we offer to high school kids while they're still in high school. They get college credit, and they also get high school credit. It's part of the College Credit Plus program. Some of the schools that are out there listening to us now were actually part of our program in the past and or are in our program now. And if you're interested, just contact us and we'll be more than happy to come out and talk to you about starting some sort of training program at your school.
Okay, let's start taking some questions now. If we can turn the robots off and we'll take some questions. So let's go to our schools right now and see if you have some questions for us. Max Hayes, we have you on our camera. Max Hayes, why don't we start with you? Do you have a question for us?
What type of motor you use?
What type of motor are you using?
Keandre, what type of motors are we using on the robots?
We're using some Vex provided motors.
Move up so you're close to the microphone, please.
We're using Vex provided motors that come in the Vex kits that we buy. They're called 393 motors. They're big high strength motors, and we can regear them to 160 RPM and 240 RPM.
That's a good question because you can have a motor that's designed for speed or for torque. And you have to figure out how you want to actually use that motor. For driving, you probably want to use torque, especially in this competition. And for shooting, you want speed. So you would change the gear ratios on the motors. Everything that you see in the Vex robot has to be a Vex product. It's proprietary. Unlike the other robot that I showed you, the Arduino robot, which is pretty much open source and you can do anything you want with it. But the Vex robot for the Vex competition has to have Vex parts.
Okay, let's move on to iSTEM and then we'll go to Newark for questions. iSTEM, and also keep in mind we have our Nordson group here, also our Beaumont ladies here to answer questions too. iSTEM, do you have a question for us?
We actually have a teacher question right now.
Hi, can you hear me?
Yes, go ahead, please.
So I was wondering if you're interested in being a machinist, what range of salary or compensation might be for somebody starting out, and whether or not it would be helpful to have a master's degree to do that.
Seth, you want to stand in front of the camera here so that...
That's kind of a hard question to answer because I was fortunate enough to get into Nordson right out of high school. I did an internship with them, so I don't really have a college degree right now. Definitely college is always helpful, but Anthony here I'm sure could touch on a little bit on that also.
Nordson itself is a union shop, so we have specific rates of pay for those designated job groups. If you were to search online, I'm sure you could come up with an income that would be viable for you. But similar to Seth, any education is helpful. Similar to Seth earlier, he had a program through JBS, and I think that prepares you very well for a machinist position. But if you wanted to continue that education or get a master's degree, I mean, that's your prerogative, and I think then you could progress beyond just making parts up into possibly designing a larger system that those parts would go into.
And also, once you actually get into Nordson, they will pay 100% of your schooling, up to anything other than your books, I believe.
That are related to the job.
Yeah, as long as it's related to something that pertains to the company, they will reimburse you for it as long as you hold a C average or better.
Thank you, iSTEM. Let's go to Newark and then to Youngstown Cheney. Newark, a question for us?
Yeah, we had a question. How high is the demand for this field of work?
And we're talking machinists,
Were you
we're
able to
talking
hear that?
engineering, design.
More robotics, I guess.
Well, you gotta realize that there's a retiring population out there. A lot of the skilled workforce is actually thinking about leaving the industry. So there's a huge demand for skilled technicians as well as higher skilled engineering groups. And the pay, getting back to that pay question, it's a great job. It's a sustainable wage that you can get. And you could get a good job right out of high school, especially if you can find a company that's willing to pay for your education once you get in. Nordson's a great company to work for. And the fact that they're offering that sort of incentive for you to start working there and continue your education is only going to increase the amount of money that you're making. So there's a huge demand for skilled labor right now.
George, we're talking kids graduating from high school and then perhaps with this robotics training, then coming to community college for a 2-year associate degree, and then being hired at that particular time, and then perhaps pursuing the 4-year degree with the help of the company.
Here's if I was in high school right now and I had to start my whole life all over again, what I would be looking for is a great job in technology somewhere that I can get with a 2-year degree, knowing that I can continue going to school to get my 4-year degree and just increase my pay. So you're right, John. You can go to Cuyahoga Community College and get certified in CAD, for example, and design things and make a pretty good wage. And you can continue taking classes, get other certifications, or get your degree and just keep moving, just keep going. There's no limit as to what you want to do or what you can do. And there's a huge demand. And the market forces are going to be, opening up these jobs real soon. There's jobs out there now for skilled labor. So, graduate high school, look for a job. If you get a good one that provides an internship, great. If not, go to a 2-year institution with the idea that you're going to go to a 4-year institution to finish up and get the highest degree that you possibly can, because that's going to yield you the most amount of money.
And I think the opportunities here out of high school, out of a community college and or the 4-year, because some individuals are interested in that 4-year degree to begin with and not working up the steps. So the opportunities are at all 3 levels.
All 3 levels, correct. You can step off at any point if you have the technical skills.
Thank you, Nordic. Let's go on to Cheney, and then the Dayton Dunbar, and then Revere.
What is your favorite project that you've worked on, and what were your challenges while doing it?
Who are you directing your question to, please? Nordson or Beaumont? Tri-C?
Norton.
Use your microphone. Thank you.
It's to Norton. Norton.
My favorite project that I work on is in the manufacturing floor. We wanted to increase the output or throughput that it would take in order to build a large product. And what we did was we went in and we studied and talked to the individuals not only on the floor but outside and the engineers, and tracked how long it took, what were the issues that were hindering the products from being built correctly, whether it was bad parts, a bad fixture, any piece of the engineering process. And so through that we were able to change the entire flow of the assembly floor, and able to increase our output and able to in turn get out more products and make sure that we spent less time on our quality issues and really driving the customer demand for delivery.
Some of the fun projects I'm working on, I'm actually kind of in the midst of right now. So as our product line develops and we look for new technology and new opportunities and what our customers need, right now I work in the UV business, so we use UV technology to cure a substrate. So a lot of your cell phones actually are coated with something inside of it that are UV cured because it's really fast and it's a very durable coating. But as we understand UV and what different types of technology can output UV, something that's been really interesting to us is LED technology. So, right now I'm, working with customers, getting voice of the customer and hearing what they're interested in and what their needs are, and then going out and looking at the market, to conferences, to conventions, to understand the growing technology and understand how we might be able to apply it into products. So it's very interesting right now.
Thank you, Cheney. Let's go to Dayton Dunbar and then to Revere. We've got about 5 minutes left in our session. Dayton Dunbar, a question for us, please.
Good morning. We do have one question. It's for the robotics team, and I have a student going to ask the question.
Is y'all things ran on gas or electricity?
Could you hear her?
No, she needs to be close to a microphone, or if you could repeat the question, please.
She wants to know if any of the motors or engines that you're using in any of those robots require gasoline or if they're all electric.
Oh, I'll go first. So for the Beaumont robots, they have to be all electric. So most of ours are nickel metal cadmium. So they're just no gasoline, just electric, and they're about this big. So I don't know about for these motors.
On the VEX robots, you're entitled to have so many motors, and they're all electric powered, and you have to really kind of figure out exactly how long those motors will last when they're fully powered, because your batteries don't last that long. So that's a real concern. Gas would be kind of cool. I mean, that would be nice. It seems like you'd probably be able to get some more powerful motors in there using a fuel like that, but right now they're all battery powered.
Okay, very good. Thank you, Dayton. And let's go to Revere, and then we'll try Northeast. Revere?
How much did one of those completed VEX robots cost? The competition ones.
All right, so let's look at this one here first. For the classroom, this is our square bot with the claw, and all the students that are in the class work on this one. This cost approximately $700 with all the sensors, okay? So it's pretty expensive. Using this robot, the Arduino robot, you're looking at about $120. Now, getting back to the question about the competition robot, if you look at this competition robot, you've got pneumatics, you've got about 10 motors, you've got the high power, high strength motors, you've got aluminum. This is really, if you will, it's tricked out. So you're looking at close to $2,000 for this robot, just to get it to the level of competing.
Okay, and one last question. Northeast, are you with us? Northeast? And how about Warrensville Heights? Were you able to connect? Nevin, are you there? Warrensville? Okay, well, we're just about out of time, and I want to thank everyone for their participation. Schools, you had some great questions for us. I hope that you've learned quite a bit this morning with regards to being involved in what we call advanced manufacturing. Nordson, thank you so much. And George and your team, thank you. And Yvonne and Gretchen and ladies from Beaumont, thank you so much. We appreciate you being here. Magnet is sponsoring a series of programs this year, and we'll be back in November. We'll get some advertising out on that program, and hope to see you then. So thank you so much for being with us today.